Hey folks, my name's Kevin and it's time for some incredibly cool knife nerdery. Today we're taking a look at two of my absolute favorite micro categories of knives. Over here, we've got what I call tool-free knives. These are knives that don't require traditional tools to take them apart. And over here, we have what I call puzzle box knives. These are knives that come apart in some kind of surprising, tricky, sneaky way. And you can tell from the way that I moved my hands right there that there's a pretty big overlap in the Venn diagram of these two categories. And that makes a lot of sense. If you're trying to design a knife that doesn't require traditional tools, that means it's not coming apart in the traditional way, so it might be kind of puzzling. And simultaneously, if you're trying to design a knife that's intentionally sneaky and tricky and something you have to try to figure out how it comes apart, well, you're probably not going to be using traditional tools. We're going to walk through every single one of these knives today and walk through how they actually work. We're going to be doing a complete or at least partial disassembly on all of these and show you the incredibly clever, weird ways that these things come apart. We're going to start off over here with the knives that don't require tools but also are incredibly easy. We're going to jump over here to the knives that do require tools but are sneaky in some kind of way. And we're going to end in this middle category that I think is the absolute coolest, some of the coolest knives literally ever made. These are knives that don't require tools and are sneaky and clever in some kind of way. They're so clever. We're going to end actually over here because this one is, I don't know how to describe it other than it's just kind of terrible. It's the worst of all worlds. We'll get to that. So let's get started. We're going to start things off with the field strip knives from Columbia River Knife and Tools, CRKT. Over here, we've got the Gen 1 version of the field strip. This idea came from Ken Onion, and he worked with Frank Huang to patent this. Frank Huang is a partner of theirs over in their factories in China. He's a brilliant guy. I've heard some amazing stories about him. Very clever guy. Gen 2 of the field strip was designed entirely by Frank. And we're actually going to start with this one because of everything on the spectrum we're talking about today. This is the least puzzle boxy of them all. It is tool free and it is dead simple how this comes apart. There's this one big switch and it shows you exactly how it moves. To take this knife apart, you literally just push this over and slide it up. And just like that, the knife is apart. It's kind of incredible. It's called field strip because it's meant to be able to be stripped in the field. And so things like the bearings here are actually press fit or maybe glued, I'm not sure. Either way, they don't come out. And so this is designed to be able to be flushed out in a stream or something like that. It's so incredibly clever. The way this works is also really clever and pretty simple. You can see on this post right here and on the back, there's this little shoulder and a little cutout underneath it. That corresponds to these holes over on this side. And this is gonna be kind of hard to see, but I'm gonna move this and slide it back into place and watch right here. Do you see that? A tiny little plate slid into place. What that plate does is slide underneath that shoulder and catch it into place. It's that simple. To reassemble this, you place this down on top, make sure this is in the up position, pop this down, and then just slide it back, and you're done. It's that easy. You can adjust the pivot tension using this screw. That's adjusting the depth of that pivot on the back, but that's all there is to it. It couldn't be any simpler. No tools, no puzzle. Next, we're going to go to the original version of the field strip because this one is slightly more puzzling. It has a really obvious toggle at the front, and that does exactly what you'd think it would do. You pop that over, and you've now released the pivot tension. However, at the back, we've got a screw back here, and there is a traditional screw head, and you could turn that with a traditional screwdriver, but instead there's this little tiny gear piece. This is not super duper intuitive if you've never seen this before, which is why I think it's slightly more puzzle box than this. But all you have to do here is turn this with your thumb. You'll notice that as I turn this, that's actually rotating that screw. And so all I'm doing here is backing that screw out. As soon as I get it to that point, now this is apart, and it's exactly like the other one. It's that simple. And just like on the other one, you can adjust the tension here with this traditional screw right there. This one isn't on bearings, it's on washers, but these two are glued into place, and so you can flush this out and there's no worry about losing any of the parts. Genuinely designed to be field stripped. The way this works is very similar, but slightly different. You can see there is a similar kind of shouldered catch piece right there, but it's not round at the top. It's actually a hexagon shape. Inside here is a corresponding hexagon shape, and in this orientation, they align with each other. But if I rotate this, I'm literally rotating the hexagon. I'm not sure if you're going to be able to see this easily or not. Oh, it's so small. I don't know if you can tell. But basically, there's a hexagon hole that aligns with that. And if you push it down over it, you can then rotate the hexagon so it's out of alignment, and it will catch on these little corners and not be able to come back off. To reassemble this, it's dead simple. You just put this back down into place, make sure this is in the open position, pop this down like that, slide that back over, your pivot's now done, and then you just have to thread this screw back in. Get it nice and snug, and you are done. So easy. No tools, no puzzle. Field strip technology from CRKT is really freaking cool. Now we're going to jump over to a knife that does require tools, but how you even use those tools is incredibly confusing. And there are no screws visible anywhere. You open it up inside and still no screws visible anywhere. If you really peer inside, you can kind of see that maybe, yeah, you can kind of see a little screw right there, but how on earth would you get at them? It turns out that this knife starts off as a puzzle box and then transitions into a traditional tool knife. This is the Cybertrix by Rike Knives. This was designed by Decklinks. He goes by King Freeman X on Instagram, places like that. And he's an incredibly clever designer that has come up with a whole lot of really neat, weird mechanical knives. We're going to see another one of his later on. This is indeed inspired by the Cybertruck, which is admittedly pretty ugly, but it's so stylized that it made someone like Decklinks, who wants to do this kind of geometric futuristic design, it made him want to design a knife. So the way this starts off, you do kind of need a tool. And like I said, eventually you're going to need a bit driver, so you will have that available with you. I'm going to use this little spudger here. What we're going to do right here is pop this back piece off. If you see those little cut-ins, that's called a compliant spring. It basically means that there's been alternating cutouts made with wire EDM that allows this to flex like a spring. And it's currently caught down around this little part right here. So we have to push it back and up. Just going to pop this in like this, just kind of push out. It's not super duper easy. Let's pop this up all the way. There we are. You can see those the cuts right there that allow this to flex like a spring. Now, once we've popped this up, this entire show side scale here can rotate downward. Now, this does two things. First is it gives us access to these screws right here. There's similar screws on the other side. Those screws are what's keeping these outer plates on. And to fully disassemble this knife, you need to take those out to give you access to the pivot screw. And I'm not going to bother taking the entire thing apart because taking that rest of the pivot screw out is just, that's how normal knives work. There's nothing sneaky after that. There is one other weird, interesting thing going on here. You can see that what the blade is actually touching up against is this backspacer we looked at. And this isn't being held in place by anything other than this show side scale right there. So the moment that we rotate this past that point, if we take the lock pressure off, this entire bar can just come right out. And look at this like little complicated line down the middle. This is so, man, Rike does really cool machining. So to reassemble this knife, you would adjust your pivot tension, do all that kind of stuff, put these plates back on top, put these screws back in, and then eventually you would put this little piece right there, slide it in like that, rotate this back up here, align it with this top piece, and then we're going to flex this spring part back down around that little catch right there, and we're good to go. So, puzzle box, you do still end up needing tools. This is another one that falls into that same kind of category. We are eventually going to need tools, but how you get started is really confusing. There's no visible hardware anywhere, and it looks like it's an integral. If we look inside, there's similarly no clues. There's two tiny screws right there that are holding this lock bar inside, but there's no other accessible anything. This is the RTWK1. I don't think it has a better name than that. It's by a newer company called Remette, and I am so impressed by the stuff that they do. The machining is incredible. Everything is so clean, and everything just works like exceptionally well. Detents are dialed super well, everything is drop shutty, and even on a knife like this that is so complicated, they're still able to do that kind of really, really great action. I've been kind of blown away by them. And they really like this kind of cyberpunky, futuristic aesthetic. And they also really like flexing their machining muscles to do clever creative designs like this. We're gonna see another knife from Remette later. So the first thing we'll notice when you take apart this knife is that there's this little tiny switch at the back. If you pull back on this, You might hear a little click. If I do it again, it's not really that clicky. It's spring loaded though. But when you do that, nothing else really happens. Like you can't just now pull this off or anything like that. If you look really closely, you'll see that there is a seam that runs along this knife right here and comes down. So that's our first clue of how to take this apart. The fact that it is sloped downward means that we can't slide this back, and it's not sliding upward, so we're gonna have to try and slide it forward. So if I pull this down and pull back like that, you see this entire top plate slid off. At this point, it can now lift up and rotate off. It actually will come off completely, but you'll notice that it's actually undersized. It doesn't want to fit back on. We're going to have to splay it slightly to get it on later. From this point forward, it's just a traditional knife. You can see we've got a standard pivot, and you can see we've got standard screws back here in order to hold this back part together. But how wild is it that this is actually still being held together completely and completely functional? Like it's still delightfully droppy and fully detent. Now you definitely don't want to use it in this version because look, the blade edge is sticking straight out the back. This top piece is an integral component. It's machined out of one piece, but it's kind of a backspacer, kind of the top half of the frame. What a weird knife. You can see that there are tiny little pegs right there and there on either side. Now those correspond to these little slots that are on the inside here. So to get this back on, like I said, this front piece is ever so slightly undersized. So we're gonna have to kind of wedge our thumb in there and squeeze this apart slightly and then slide that down onto place. Slide that there. And if you remember inside there, those slots have to line up with this. So we're gonna push this down like that. And now that we are aligned in this direction, we need to slide this whole plate back. And we're done. And it's incredible, since this entire piece comes off, that they're able to make it be so exceptionally flush. The clearances here are basically non-existent, and to do that, they have to maintain such incredibly tight tolerances. Remette has actually played with this idea of hiding the screws underneath some kind of removable but sneaky scale part on other knives as well. They've got one called the Peregrine Falcon, where the plates on the outside come off with spring tension post right here. You basically push that in, slide the entire scale off, and that's how you get at the screws to take the knife apart. This is an exceptionally cool knife. You gotta check Remette out. Okay, we're finally in the true full tool-free disassembly and puzzle box hybrid category. And we're starting things off with the CKF Custom Knife Factory Snecx Terra. This is a production knife that CKF did that is loosely inspired by Snex's original knife. Snecx Tan is a brilliant machinist and industrial designer from Malaysia, and he got his start designing a true tool-free puzzle box disassembly knife that he called the IFS-20. Now he took some of the approaches from the IFS-20 and adapted them to something that's a little bit more easy to machine. They're doing some really weird fun stuff here. And again, we don't have anything that looks like traditional hardware. There's lots of things, but none of them have like a screw head or anything like that. This is also doing something really strange in how it works down here, because if we look, this is a lock bar, but that's also a leaf spring right there. And there's a detent ball that we can see right there. That's not the detent ball. That ball doesn't go into any kind of hole. When we close that, that doesn't pop in anywhere. It's that side that popped in. Did you notice that? There's actually a second detent ball, the thing that's actually acting as a detent ball, on that side. Ball on this side is only there to run along the blade and reduce friction. Now, why would you design it like this? One reason is that you now have spring pressure coming in from both sides, which helps with centering. Normally you have the leaf spring lock bar pushing the blade off to one side, but here you're able to apply pressure from both. The other reason you might do this is to separate your tuning of your detent pressure from your lock bar pressure. Ordinarily, those two things are tied. To have a stronger detent ball pressure, you have to have a stronger lock bar pressure, which means more friction during the rest of it. Or if you want to lighten your detent pressure, you have no choice but to lighten the spring tension on the lock bar itself, which could introduce blade play. So by putting your detent ball on a completely separate leaf spring, you can tune that however you need to and not have it be connected on this. But that has nothing to do with how you take this knife apart. So let's go look at that now. At the back here, we've got this backspacer that runs the entire length, and you can see that there's a post right here that it kind of wraps up over. That's our first clue, because this is actually flexible. It's barely flexible, but if you look, I can technically flex it down. It barely looks like it's moving. But if I do flex it down, it's going to give it just enough room to allow you to pull that piece out. With this pulled out, we can now pull this backspacer back up, and this whole pin can come out. Now what was happening is that this hole is slightly out of alignment with these holes and allowing it to catch on this notch part in the middle. By flexing it down past that, you're able to align it with these outer slots and let this entire piece come out. Now from here, you might get stuck. Where do I go from here? Like what comes out? This is still in place. This is able to splay slightly, but it's not coming apart. There's no other screws. And that's when you might notice that if you take this piece out, this back part right here is the exact same shape as these holes right here. So technically speaking, this knife does have screws. This is a reasonably standard screwed pivot. It just uses proprietary screw shape, but it provides you with its own tool. This pops in here like that and becomes your pivot tool. And you have great leverage with all that. Now, I'm not going to take this the rest of the way apart because once you do take this apart, first of all, it's just like a reasonably standard screw disassembly. It just comes apart like that. But also there are loose bearings inside. And so this is the exact opposite of meant to be field stripped. Those bearing balls can fly everywhere and there's a bunch of little pieces. So you definitely don't want to be taking this apart in the field. If I were to take this all the way out, you would see one other cool thing. These little parts right there, those are the back of those two leaf springs, the one that is doing the detent and the one that is doing the lock bar. And there's nothing holding those in place in terms of screws. They're just being notched in right there and then held in tension. It's a really cool design. Technically speaking, there are screws deep in there that are holding these plates on if you get one of the versions that have a plate right there. But those are the only normal screws in the entire thing and they don't ever need to come out. To put this back together, you would just stack it all back up the way you do a normal knife, and then you would use your clip-turned pivot screw again to tighten that back down to tension. Once you have it the way you would want, you then put this little post back right there and slide this down into place. Put this back through here. Start sticking it in there. And then again, you will need to push this down just enough to be able to slide it past those and click it into place. And you're done. How cool is that? Next up, we have another one that is very sneaky. This is another design by Techlinks. This is the Rebel ship, and it's another Rike knife. And this one is very confusing to take apart. There are absolutely no screws anywhere. Nothing seems to move. You can kind of feel there's like a slight jiggly thing right there, but there's no anything. Nothing seems accessible. And everything is so incredibly aligned. There's so many little details that they kind of lead you astray. It took me a while to figure out how to do this one the very first time, but let's talk about it now. The sneaky part here and the little bit of clue is that there is an arrow-shaped triangle right there. If you push down on this, you'll notice it is ever so slightly flexible, similar to how this is ever so slightly flexible right there. If I push that down, this back piece can now slide out and come out. This piece here can then slide up. Now I'm going to be honest, I don't know why they did this. This isn't really necessary. I can't think of any particularly good reason why they made this a separate piece, but they did. Now once you have this out, you'll get kind of confused again. How do you move forward from here? Because nothing seems to move. You'll notice a little kind of line right along here, implying that maybe this slides in some way, but it won't slide anywhere. And the very first time I did this, I got stuck at this stage for a minute before I realized that you have to then open up the blade before you can proceed forward. Once you've opened up the blade, it turns out that this piece here can now pivot downward and rotate up like that, which then allows this piece to slide out and lift up off. You can see this being held in place in part by that little ledge right there that slides under there, and in part by this piece right here, this teeter-totter piece having this post that comes up. That's blocking this channel or not. And this slot right here is what slides around that piece right there. Now at this point, again, moving forward is kind of confusing. There is a similar slot that runs down here that implies that this piece could maybe slide off. And if you read their instructions, they claim that technically speaking, maybe you can slide this off at this stage. I've never been able to, and it's because it's being held in place underneath this pivot part right here. This is the backside of the pivot. The other one was free sliding, but this one is quite wedged in place. So this is where they take another cue from the Snecx Terra design, and this backspacer becomes your tool again. This tiny little notch at the front aligns with this little screw right there. And at this point, you could just back this screw all the way out and take this side off and treat it like a traditional knife. But no, let's get sneakier than that. Let's back this out just a little bit to release the tension. And then, as long as we have this teeter-totter piece down, we can finally slide this piece forward. This lifts up, and you'll notice that unlike the other side, we actually have a little wedge action right there. That's what's wedging underneath a shoulder on that little pivot part. Now, to keep going, if you want to, you can. You can then slide this pivot down. I'm gonna have to move that lock bar out of the way. You can slide this pivot down, kind of wiggle it past here. And if you move it down far enough, you can then slide this clip up and off. Now, you don't need to do that. It's really difficult to do. You have to lift this piece up over because you see it sitting down in a little tray down there. And then it's also being held in with like a detent bump on the back. So it's actually pretty hard to get this piece off, and there's no reason to do it, but you can technically take the clip off without any kind of tools either. But I'm not gonna bother doing any of that, and I'm not gonna take this all the way apart because there's so many little pieces here. But you can, and you can see that you can now see the pivot point right there for that piece and how this can flip up around. To put this whole thing back together, you need to align everything up, push your pivot back through, and then you'll be able to slide this piece back in place. Now, it's important that this little teeter-totter part is facing down. If you accidentally put it like this, it's going to not be able to come back down because it needs to ride inside this channel right there. So this has to push down like that and then slide on top right here and slide back into place. Now you can teeter this back up, and I think I probably need to adjust my pivot tension slightly. Yeah, I gotta tighten this screw back down just a bit. And it's actually at this stage that you wanna check your centering. If we come down here and look at how this is closed, you can see that my centering is off. So I need to adjust my pivot tension so it's gonna be centered, because I'll show you in a moment why that really, really matters on this knife. So we're gonna get that down, get us back to center. How is our, ooh, that's nice and good. Do we have any blade play? No. Okay. So to put this last piece on, we need to push this teeter-totter back down. The blade does have to be open. If the blade is closed, you'll see that it hits that back up into spot, so you can't actually reassemble it. So we have to have the blade open, teeter that down, slide this plate into place, teeter this back up, pop this little piece back into place, and slide our key back in at the very end. Now, this notch right here is why that centering matters so much, because look at where the blade sits. Ooh, absolutely no room for error. This is probably the most complicated of any of them on the table. It's definitely not meant to be field stripped. We're going to jump now to another one from Remette. This is called the RT-Kingfisher, and this is another knife that I was just kind of blown away. Remette does such an incredibly good job. Everything is so clean. I've been really surprised by how cool their knives are, and they're so creative with what they're doing. This is another really clear example of them being able to push the boundaries of how this stuff works, because this is actually really easy to take apart. It is field strippable to a degree, but it is still a puzzle box knife because, again, we don't have any traditional hardware showing except for this pivot screw, and that's not a normal screw. But if you look, we'll see similar slots right there, like we saw on the back of the Cybertrix. So indeed, this is another compliant spring. But unlike last time where we had to use a kind of tool to pop it out, you have a nice little lanyard spot right there that you can pull out on, and that slides this up. This then slides up and slides down, and this is our backspacer. Now there's a cool little feature in how this works right here. This hook right there is what's catching on this backspacer pin. But you'll see right there and there are these little tiny catches again. Those correspond to these holes right here. So when this goes into place, this part there is pulling this back, and these parts here are pulling these two sides together around those pegs. Because with this out and not holding those pegs in place, this back part can just kind of come apart. But from there, how do you go forward? Well, this is another case where this backspacer ends up working as our tool. This little slot at the front fits perfectly in this spot right there and allows us to unscrew this front pivot. Now, I'm not going to keep going because this is just a regular screw at that point. Everything is like a traditional knife. There's regular bearings inside. And so it's pretty straightforward, but it's really quick and easy. This is so easy to take off. It's pretty easy to back this out with it. And it's just kind of simple. To put it back together, you would reassemble the way you would a normal knife, put your bearings in the right order, and then tighten this back down. And then simply hook this back on that top part and pop it down like that. This is by far one of the easiest, and it's so well done. Okay, last up in this category is by far one of the coolest. This is a complete puzzle box knife and tool-free disassembly knife, but importantly, this is the only one in this category, at least in my collection, that doesn't have any kind of screws in it. Now, all of those previous ones we were looking at, they have a traditional pivot screw, but some part of the knife becomes the tool you need for it. You don't need traditional tools because it is its own tool. This doesn't work like that. This is being held together in a completely different way. Now, this is the Avian Knives Atlas, and this is an incredibly clever knife. It is loosely inspired by the way that the original IFS-20 works, the one that I said Snecx did before making the Terra. But it's not a copy of that by any means. It just uses similar-ish techniques in a couple areas, specifically in how this pivot tension is being done. Avian Knives is a collaboration between Reate, aka Tactical on Instagram, places like that, and Seth Taylor, aka GDS Knives. He's a custom knife maker. And this is actually from the very first batch they ever did of these. These days they're on what they're calling Gen 2.5. I'm not entirely sure what's actually different between Gen 1 and Gen 2 because they're fundamentally the same in terms of how they come apart. I know in Gen 2 they have a new like shim washer system to allow you to fix stuff like centering as things wear in over time. But like I said, everything in terms of how you take it apart is exactly the same as Gen 1. So how do we even get started? There's no hardware anywhere. There's no screws inside anywhere. There's nothing. But if you look close enough, you'll notice there's this tiny little piece right there. And there's a little kind of spot you could maybe get your fingernail into. That will pop out. It's being held in place by a little detent ball right there that goes and corresponds to that hole. And this starts to rotate. And if you look back here, we'll notice that this is actually rotating that little tiny peg at the back. If we rotate it up, that peg now aligns with the hole, and that allows this clip and backspacer piece to slide out. This now comes apart completely. We now have this entire backspacer piece that can lift up, rotating about a little pin right there. Now from this point, how do we move forward? Because there's no additional screws anywhere. This is kind of just held in place with stiffness. So what do we do from here? These little pieces right here look like they can kind of slide, but this one doesn't go anywhere. But if we notice, there's no front part to that piece right there, which means this piece can slide out. And it's actually this piece that is providing our pivot tension. This is our pivot. And it's this little ramped wedge right there, sliding under that, that's holding all of the tension on that pivot. With this out, this pivot can now push down through and come out the other side. And we can take that piece off. There's now nothing holding these two sides together, and this entire piece can just kind of pop out. That's the entire knife. We've got standard bearings in there. Those look like skiffs to me. They might not be, but they look like they are. And there's no screws anywhere. This is just a post that holds the back part on. This is a very similar looking post that holds the front part on. Just got a bigger shape there. And there's so many little pieces, and they're all so intricately shaped, and everything has been so incredibly machined out. It's so lightweight. It's so cool. To reassemble this, we need to put this back through there and back into this side. The alignment here doesn't matter, but I'm going to arbitrarily turn this for my OCD purposes so it lines up with that. Place this piece back on top of here. Now at this point, we need to put our back cap part on, drop this down into place, and we just kind of need to align these backspacer pins like that. We need to slide this piece back up under there and wedge it in place to get that tension. Pop this back down, put our clip back into place, slide our post in, and before we can put it all the way in, we got to take this little piece, align it into position, and rotate this so that it slides through. And then we can pop this back down, and we're back together. It is such an incredibly cool knife. Okay, this is the last one. Now, this is, I said at the beginning, just kind of terrible, but that's in some ways not fair because this is a really cool knife. It is so incredibly cool from a stylistic perspective. Amazing lines to this. It's got a fantastic hollow grind. It's beautiful in the hand, just so ergonomic because there's 3D contouring everywhere. It is wildly skeletonized inside. There's cool ventilation holes right here. This is absolutely Reate flexing their machining prowess. So why do I say it's terrible? It's kind of the worst of both worlds. This does require a standard tool, but it also requires a proprietary tool. And the way you use this is puzzling. It's not obvious how this knife comes apart. So it's kind of the worst of all of the above, but it gets even worse because this tool is not strong enough to actually work without bending and breaking. So I will talk about that in just a moment. How do you take this apart? The front part is just a standard pivot screw. You just take that out with a regular bit driver. It's nothing special. But the back part, there's no screws anywhere. And that's when you notice that there's these little holes in this rotating spot right here. And this is actually very similar to this original one we looked at, where you have a kind of geared part right there that allows you to rotate that screw. The big difference here is that on this one, the screw is only going in one side. On the other side is free spinning, which means you're basically unthreading one side from the other. And it's really easy to do because you have access with your thumb. We've got a similar concept right here, but it's much more complicated than that because this is a collar around a double-headed screw. One side is screwing into that side and the other side is screwing into that side. And you know how when you put a screw in, it's a good idea to kind of back thread it a moment until you hear it pop into place and then go forward. That way you're not accidentally misaligning. On this, the threading on these two sides have to perfectly align with each other. If the screw is aligned with only one side but not the other, you'll be threading into one side and cross-threading into the other, like reverse threading. That's because the threading on one of these sides is actually the opposite direction. So one of the two screw sides is standard lefty-loosey, righty-tighty, and the other one is mirrored from that. And they have to be perfectly aligned. So how do you even take this out in the first place? You're supposed to take this tool right here and hook this on like that. You're basically putting that little peg down into that hole, wrapping this around, and now applying pressure in one of these two directions. This way, I think tightens it, and turning it around, hooking on the other way, this way I think loosens it. It's effectively a spanner wrench. The problem is that this is made out of titanium, and this tiny little peg right here isn't all that strong. And so if this is tightened down, or worse, if someone's put Loctite in it, like my friend who I bought this off of, well, this is simply not strong enough to break that tension. And so on multiple occasions, on both sides, notice they give you two, these just kind of bent over. I was able to bend them back so that it looks right from an aesthetic perspective, but these are no longer strong. If they bend over again, they'll probably just snap off. And so to actually disassemble this, I had to order an appropriately sized 5/64 inch hardened steel rod from McMaster Carr, pop it in there, and use my leverage to finally break that seal. And like I said, reassembling it is an absolute nightmare. You have to somehow float this screw in exactly the right spot before you put this in, align it with both of these in a way so that it's correctly threading into both and not cross-threading or reverse threading in the other one, and then spin this piece back around. It is really hard. It took me probably an hour of fighting with this knife to finally get everything realigned. And so no, I'm not going to take it apart right now because this was an absolute nightmare. So there we have it. I absolutely adore stuff like this, especially these intricate little puzzle box ones where there's a bunch of little parts and they all have to go in a certain order. I find this kind of stuff so incredibly fun. My brain has adored stuff like this since I was a small little child. I cannot get enough of it. But the other side of it, where things are tool-free and very, very practical too, is still just so clever. It's so satisfying. So hopefully you enjoyed watching this video. I definitely enjoyed filming it. I'll catch you all next time.